So hope you guys subscribe to my channel. This is my geometry lecture video. And yeah, if you find any question for my video, then just comment below. Then you can so in the weekend. Okay, so this video, let's talk about reduced schemes. Okay, so I think previously I already defined a reduced scheme, but I need to. So in this video, that we will approve lots of equivalent condition. That's it. So if you want to check the example, then you can check it. But I think previous that we have proved. So you can use this criterion to check that whatever ring is reduced, or whatever scheme is reduced or not. Okay, so there's a main definition, and actually they're all equivalent, so we will prove. But however, so I will give the first definition. So if somebody gives you a scheme, reduce. So this is one definition. All the stocks, right? Stocks is a ring, is a reduced. It's a reduced ring. Okay, so immediately we need to prove the following theorem. So XOX is reduced in if for all open set U, OXU is reduced. Okay, so here comes the idea, right? So here comes the technique that you need to play around with. It basically still the same, right? Global to local, local to global, right? So now you're saying that actually it is fine. At least property reduce. At least reduce property is can be translated from global to local or local to global. So there should be one direction which is trivial. Hopefully you can see this. So this direction is trivial, right? Because I mean, if for all XU is reduced, for all U, right? That means that obviously that if you take any point, right? If you take any point X, right, then you can find open set U which cover it. So in the Stokes representation, you are just writing you're just writing a F, right, and U. Okay. So now if OXU is reduced for all U, basically means that well, obviously that if you write as a representative, let's say this is Stokes, right? So let's say you choose this is element, let's say this is element O of XX, right? Then in this case, if this element is nilpotent, right? Let's say f is 0, right? Okay, so if there is an element which is nilpotent in OXX, that means that there is open set U such that when I write FU, this means Fn is 0, right? But OXU is reduced for OU, right? So this can mean that F is 0. So if F is 0, then sure that all of X, this F will be 0, right? So all of X's will be reduced. So this is just simple, right? Because your Stokes is defined to be the shrink of the open set, right? So if you have some guy which is 0, you have some F which is to some power 0, that means F for some open set, this guy is 0. This F to the N is 0 in some U, but for every U, this guy is reduced. So you prove that. Okay, so this direction is somehow just definition of Stokes. Okay, so another direction is a little bit tricky, but since we have the powerful proof, right? We have the powerful tool that I say before, is that given any sheaf of module or whatever your F of U, if you take this, you can check out my previous video, my list of video. There's called sheafification or some property of this sheaf. So you have this kind of map, a product of X to U, F(x(x), F of U. And there's my previous video. There's an important result that these guys injected. Okay. I think I proved it by some of my video that you can check out. Okay, so but if this is true, then simple, right? We can just apply it. F on OX, right? So just apply F equals OX. So this means that OXU means that X belongs to U, right? So O of XX. Okay, so now if I take the element S, right, and I say that X is 0, right, then this translates into X for hx, right? Maybe so it translates x belongs to u as x to n, right? Maybe somewhere, yeah. So s mapped as x. Okay. Okay, but now this guy is reduced, right? So this means that all this x n is 0, or implies that x is 0, right? But this means that this element 0 from right hand side, and this map is injective, so s must be 0. S must be 0 because this guy is injective. So if the right hand side is 0, the left hand side must be. Okay. Proof just that's it. Okay, so we prove. Okay. So proposition is very simple. That an affine scheme. If I'm working on an affine scheme, right, then the affine scheme A is reduced. If only if A is reduced. Okay. I think I don't need to prove it, right? I don't need to prove it because if I say affine scheme is reduced, then I just need to check that every local or every stocks is reduced, right? Or any points is reduced. Right? So basically you just need to check. So you just need to check. Okay, you just need to check if A is reduced, then AP is reduced, right, for each prime. Simple exercise. Or you can check out my other videos. I think in the future there's a video called affine. I will talk about idea called affine local, and then maybe I will prove detail. But I mean, you can check this. Okay, yeah. And by definition, if A is reduced, then you take the global section, right? So there's spec A. So this property is so important that you should remember always. Okay. So if you take so this is just for spec A, take a spec A. Right, so if this guy is reduced, then this guy will be reduced. Okay, so these directions is trivial. It's trivial by definition. And the other directions is that if you want to prove A is reduced, then you just need to choose to prove this. Also simple. Okay. Yeah. Okay, so now we're gonna prove the important results. Basically, saying that. Oh, I think. Okay, so let's take a look at this proposition. So this proposition is also sometimes used. Consider x is always the scheme. Okay. And the first stage x is cube. So using our definition, basically every stock is. Okay, the second statement is that there's a file open cover. Cover x union ui. Okay, and these ui are reduced, so its global section is reduced. So ui of x. Okay. And there's a 3 where for every file open. So this is open recover, right? So this is for every file open something. These guys reduce. Okay, there's a first statement is that for every open set equals s, or still is reduced. So the fact is that 1, 2, 3, 4 are the following. Yeah, so we get the following are equilibrium. So 1, 2, 3, 4 are the same. Okay. Okay. So I think as we proved that these, as we previous, right, we already proved this is the same. So we just need to show that 1 and 2 and 1 is 3 also. So 1 equals to 2. Okay, so do we need to prove it? You need to think a little bit. Okay, so 1 equals to 2, right? If you have right, since I don't force equivalent to 1, right? So obviously that if 4 is true, then the whatever open set is reduced, right? So basically say that 1 implies 2 is just, right, since 1 is equal to 4. But for 2, that the only thing I need to do is prove 2 implies 1. But this is simple, right? Because things, so each of, we already know that since each of my open cover, I can cover this by 2i, right? So that means that each stops is just the ring, right? It's just the spec of let's say a spec of, let's say UI is a spec of AI, right? So I just take a spec of AI, then take, yeah, so each stocks is just spec of AI, that space, and then take the stocks, right? So this take, if you take the stocks, then will just be some ring and localize that by prime, right? But the things, as we say, right? So since these guys reduce, so this is as a fine scheme, right? So it's a fine scheme, and if A is reduced, then all the prime duals is reduced, right? So these guys are all reduced because now you're a fine open cover, that ring is reduced, right? So it's all the small guys are reduced. Okay, so prove just that. Okay. So now let's prove the 1 is the same as 3. Okay. As we say that, right? So 3 is the same as, just say that for all apply, right? You restrict it to all apply u belongs to x, that always reduce. Since 1 is equivalent to 4, right? So 1 implies 3 is trivial, right? So 1 implies 3 is trivial. So the rest is we need to prove that 3 implies 1. We need to prove that 3 implies 1. Okay, so proof. Yeah, this one. So 3 implies 1. Okay, so we say that this guy is reduced, right, for all by open. Right, and then we just cover x by this by applying cover and use 2. Right, that's it. Okay, so very simple that these are all these are basically simple. The most important one is this proof. But if you notice that the rest are trivial. And there's an idea called find local that I will give in future meetings. Hope you guys subscribe to my channel. Thanks.